Now, there are some high net worth individuals in the world who will spend their money on things like super yachts and incredibly ugly, newly built, massive mansions that look like a fake Versailles, which have huge gas boilers and consume an enormous amount of fossil fuel energy just so that their owners can show off. And anyway, it makes me sick. But there are some brilliant, with enormous foresight, people who will build a house. This is a house. It's amazing. This house uses zero burnt energy. It uses zero fossil fuels. It generates power. This is a power station that is also a house. They're installing new technology now. They're constantly updating it. What they're doing here is truly remarkable, and it will, in time, become far more commonplace for our normal houses, for normal people to live in. So, welcome to Moonstone House, and welcome to Fully Charged. So John, just go back briefly, because this is such an extraordinary house. You just get blown away when you arrive here and go, basically I walked around all the time I was walking around, I was just going, But so tell me when you started it. You started it?
2002 we started with design.
Right.
It took 2 years to get planning permission and convince them that we could build something. And then from 2003 onwards through to 2009 we finished the build, and it was a hands-on job, so it took us a lot longer than we anticipated.
But it's a massive house. It's an incredibly visually impressive house, but it's the kind of technology that's running it that is obviously where my interest is.
I think with Moonstone particularly, when we designed it, my favourite technology is the most stupidest technology, which is insulation.
Right.
So we designed her with a meter's worth of insulation. She gave a U value of 0.06. It was way beyond passive house. It was way beyond anything that people were talking about at the time. So we're talking about zero net greenhouses and code 6 and stuff, and she exceeds all those levels. But we had to do that at the beginning before we started introducing all the technology.
Right.
So for us, we could have strapped solar panels on in 2005 to 2006, but it
really
was hideously expensive, and we just added to the technology. So yeah.
But then, so what's so interesting though, since you've done it, since it was finished, you haven't just left it, you've kind of continued to improve it.
So basically, so Moonstone's evolving, but the core technology stays the same, which is she doesn't lose heat.
Right.
She doesn't need heat. So although some of my blogs will show me doing underfloor heating, that was literally, if I'd gone bankrupt, trying to sell a house which is 17,000 square feet with no heating, would be ridiculous. Yeah. So we put it in.
Right.
We don't use it because there's no need. So that's crazy. And most people go, financially, why would you do that?
Yeah. So Kane, you've been involved in this house since inception. I mean, I've got to say, it's an incredible house, but it's just slightly mad.
It is.
It's so enormous. You'd think that all the things you think about is this, God, imagine heating that place, or imagine like there's got to be the expense of running it, apart from building it. Let's not even go there. But that isn't the case, I'm assuming.
No, so right from the beginning, one of John's remits, when he explained the house to me when I first came here, he talked about the insulation and how the building was going to store as much energy as possible. So straight away, we automatically went, well, in that case, we don't need to generate huge amounts.
Right.
We do at the beginning. So when the house first turned on, there is underfloor heating. When we first turned the house on, it took about 6 to 8 weeks for the concrete to warm up and the house to get warm. Once the house had heated up, the heating hardly ever comes on. It actually doesn't really come on. We did a calculation back about 10 years ago that we think that the underfloor heating pump probably uses about £70 worth of electricity a year to pump the house to heat. When the system goes off, the floor stays at a constant temperature for weeks, 4, 5, 6 weeks before you see a drop off in temperatures.
Right.
So knowing the insulation levels were going to be so good enabled us to think about the way that we fit the systems. So we did the heating system, made that as efficient as possible. We looked at the lighting, made that as efficient as possible. We looked at the way that John was generating hot water and the way he was generating electricity and how we could use that and how we could minimise the electrical input into it. So that was done right from the beginning, but it all came from John's vision of the house.
Right. But so is that the insulating material you used in the house when you built the house?
So yes, so it's not very environmentally friendly. It is an extruded polystyrene, but basically Moonstone has approximately, there's 5 pieces of this insulation which is totally waterproof. So that, with our stone cladding as well, gave us about
that's the thickness, that's how much you've put in the walls. Oh, wow, that is amazing.
And that is then replaced by this, which is basically a VacuPore product, which you can probably see is around about 10 mil thick.
Yes.
Now,
and that, seriously, that has the same insulating quality as 5 thickness.
Yes, which is probably equivalent to about 1 metre and a bit of rock wool insulation.
Yeah. So just to make sure I understand it, when you say that, so there is sort of underfloor heating. So there are the pipes of effectively hot water running through.
Yeah, there's eight manifolds in the house.
But then how is that heated? How is that heat?
So John has a ground source heat pump with slinky style pipes, and he also has some boreholes. Right. The borehole is the most efficient, so that effectively most of the heating for the underfloor heating comes from the borehole.
And that's a hole that's drilled.
Yeah, in the field next door. Right. Yeah, and then he's got the solar thermal, which tops it up. So on a good summer's day, you see 100 degrees. We see over 100 degrees C, almost. We're having to deal with that energy. That was, but again, that was something we discovered after the systems went live. Right. We knew we were going to have the ground source. We knew we'd have the solar thermal. Yeah. All we had to do is get that water pumped around. But then the concrete of the house is a massive heat sink, so it absorbs all that heat and stores it. So we end up with a huge amount of excess heat.
So there's 2 ways that this house generates heat and power. This is heat. Those are water heating. It's solar water heaters, massive ones, quite old-fashioned now. They've been there a long time, but clearly immensely powerful, and they produce an enormous amount of heat. They can generate steam. They can generate 100 degrees steam temperature water. On the roof of this building here, which used to be a piggery, will be 60 kilowatts of solar. So there's 10 kilowatts up there at the moment. There will be 60 kilowatts. That will be exported to the grid. And you can just probably see somewhere over there the 3-phase connection. So they've got a very powerful connection here so that it can export a lot of power. So this system produces way more than even this house can ever use, even a big house like this. But it's not too much for the car. So John has a Tesla. He can plug that car in. He knows that all the power that's going into that car is coming from the solar. Very impressive. So this is the plant room of Moonstone House, and it is quite, as plant rooms go, it's fairly impressive. What we're seeing though, this is the basics of it. So out in the field there, great big hole bored in the ground, really deep. Fluid is pumped down there, it goes round, it gets warmed up, it comes into here. This stores the heat through this massive pipework in these two massive tanks. So I mean, it's really warm in here. I don't need gloves and a hat on and a coat on in here. So that holds the heat. That heat then goes all the way around the house. That heats the entire house and the swimming pool and everything else. I mean, it's an extraordinary system, but there is nothing being burnt here. And as you can tell, it's on now. It's quiet. There's nothing really going on. What's happened, in fact, is they extract so much heat, they don't know what to do with it. So they dump it in this. This is the pool. This is like a heat battery, if you like. This is the swimming pool. I'm guessing 15 to 20 metre long lap pool. And that is full of really, really warm water. Well, that water is like a heat sink, and that can be used to heat the house. They've got too much heat. What this says to me all the time is, every new house should have a ground source heating. That's the obvious way to heat things. People do it in other countries. Scandinavia, they've been doing it for decades. Why aren't we doing it in this country? Sorry, just my little rant. So now you're having more solar put on and batteries. So you're putting power walls.
Yeah. So now we go truly, well, I'll say off grid, but a friend of mine will actually be bold enough to step in to say we're literally going to being a power generator, right, yeah, or a grid stabilisation unit, for want of a better word.
But then, so the other aspect that's a bit happening now is, you know, when you originally built the house, the notion of solar panels and batteries, we could probably understand it, and people could talk about it, but it would be so prohibitively expensive, and no one made stuff like that. Yeah. I mean, they just didn't exist. The products didn't exist in many cases, but that has really changed. So that's what's happening now. You're upgrading the solar. Yeah,
so what we've, right from the very beginning, in order to see where energy was being used in the house, back in 2010, we installed a quite advanced energy monitoring system to monitor every circuit in the house. That was intended to work out where we could save energy, electrical energy we're talking now, where we could save electrical energy, and where it was being wasted. The solar was clearly generating far more energy than we needed at the time, and it still is today. So one of the natural, it's almost a bit late, but the cost of the batteries has made it more achievable now. And that is what we do with that excess solar. So the excess solar now we're going to capture into batteries and then use that in the house. But at the same time, expand the solar generation as well, from the existing 10 kilowatt to what will effectively be a 60 kilowatt solar array.
Wow. I mean, I think it's more, just to put that in context for people who maybe don't know that much about it. You know, your average house in the UK, for example, will have 3 to 5 maybe kilowatts, and this is 60.
Yeah. So this is more than what the house needs. Far more than what the house needs. This is the next stage.
From the point of view of charging cars, you know, that makes a big difference. If you can charge a car for nothing, that's really.
Yeah, and the other thing as well is, if in case of where the location of this property, there are power cuts. Right. So that's another aspect of where it will be very useful. When we have a power cut, the house will still be live.
Yes. But I mean, I think it's really important to point out that what this shows us is that, you know, yes, if you've got the money to build a house like this, it makes much more sense to build it like this one has been built in terms of its longevity and how much it costs to run. But if you're building, say, on this exact same site 25 houses
you
for
do the
normal
same thing,
3-bedroom houses. You could do exactly the same. You could heat them all, no gas boilers, nothing.
Communal ground source, communal air source.
And if you're doing building work and you're digging everything up, well, drill a hole.
Yeah, and we see that. We do see that around the world. In Australia, very much.
Yeah, but not that much here.
So the real kind of challenges we faced here is integrating it all as well. So making sure they all talk to each other. There's no point in having all these systems that are over-generating, but we're not using that. So making sure that the ground source got to the swimming pool with the minimum amount of energy to pump it, that became the challenge. Making sure that the underfloor heating was linked to the outdoor temperatures and the actual source temperatures coming in, that was key. So integrating it was the real challenge here.
And also all those houses could generate, they could all be net exporters of power.
Well,
we know that.
your channel has been an advocate of that. And it just, the message just needs to get firmly out there. People need to start realising that you do not need to light a flame, gas, oil, get rid of it. Can it be done? Of course it can be done.
Yeah. I mean, that's what I think it's, I'm really full of admiration for what you've done here, is seeing that. I don't think I could have worked that out when you started building.
No, we've made mistakes.
I'm sure. We all made boy, I've made plenty. But I mean, to think, let's build a really big house that is so well insulated you don't need to burn gas to heat it. That is a lot of foresight there. It's really good that you've done that.
I think foresight probably is. I think it's a passion. So I couldn't have known it could be done, but all the other the countries, your Norways, your Scandinavian countries, and Germany, were doing quite a lot of this stuff. So we just took it to an nth level, and any accountant on a piece of paper would just say it doesn't pay itself back.
Yeah.
Well, what's the cost of the bloody planet, for Christ's sake?
Yes.
It doesn't need a cost itself. You build a house once, leave it, do not take it apart.
Yes, I mean, that is the thing I think that this technology is revealing, is that in the past we've gone, what's the cost of running my diesel car? And you're looking at it like that, you're not looking at this. And there is a cost out there, which we're all now extremely aware, So.
I think certainly, with recent events, certainly we're just more aware of that. I think we should be moving in a direction to just this abandonment of this fossil fuel. Careful what I say. This fossil fuel industry. It's ridiculous. And maybe with it there weren't really wars. Oops.
Right, cut that. That's too radical.
Too radical. Sorry.
And are you seeing then generally, not just in this house, but in all the work you do, that this technology is now being adopted a bit more? Are people more interested in it?
Yeah, so it generally tends to be, because of the price, it still is a little bit prohibitive. But most of the installations we do now, there is a conversation, a discussion regarding the value of solar and batteries. It is a value equation to all of these customers. Some customers generally, if they already have adopted, the best example, if a customer's got a Tesla, it's a no-brainer for them. It's an automatic thing. If they've not made the electric step yet in the car, they then make that equation whether it works in their home. But we are seeing a lot more inquiries for it.
Right.
What John's real interest here is about where we go in the future. So what we're doing today is putting an extra 50 kilowatts in. It makes it 60 kilowatts. This house, at the moment, we're in the effectively, I think it's 25,000 square foot house. It's pulling about 500 watts, and which is incredibly low for the size of the house. So we don't need a 60 kilowatt system at all. However, in the future, John's thinking about how we can support the grid effectively. So that's where we're going now. It's to showpiece what you can do with solar and batteries in a domestic property for the sort of the virtual power plant technologies, and that's where the next step is for this property.
I mean, and that's the critical thing is, I've always said this, and it's boring, but my house doesn't make any difference. This house, in terms of the grid, doesn't make any difference to the grid yet. But if there were 1 million houses like mine,
cloud management
and they had batteries and solar, then
it's the exciting part of this. This is the next stage.
We need like 25 less power stations. That's because people always talk about, if we have electric cars, we'll need more power stations. No, in fact, it's exactly the opposite.
Yeah, especially with storage in cars, storage
Yeah.
in the home.
Yeah.
Maybe you can envisage a scenario where there isn't a power station because everyone's
Yes.
doing it themselves.
Yeah.
All you need is some management of that grid.
You need a very clever bit of grid work.
Yeah.
So what is really impressive about this extraordinary house isn't so much that it's a massive, it's just huge. It really is very, very big. It goes on for ages. But it isn't that so much. You know, there are lots of people have built massive sort of rock god mansions and things like that. That's not what this is about. This is about showing that it is possible to have a large property like this where you burn nothing to maintain it. There's no gas boiler hidden away in a corner. There's no burning of any sort that takes place in this house, and yet it is really warm and dry and secure. And what this house is equivalent of is about 26 normal houses. And it's incredibly plausible when you see the infrastructure that he's put in here. If you're building a new housing estate with 26 houses on it, there is no excuse any longer. You don't need to put 26 individual gas boilers in those houses. It is absurdly expensive and wasteful and stupid and short-sighted. And this technology is really important that more and more people adopt it in more and more cases. So very obviously John has built an amazing house here, and it's still developing even to this day. They're putting more solar panels on. It's amazing. Anyway, that's all we've got time for. Please do subscribe to this channel. We've got lots of more amazing shows coming up. Please have a look at the Patreon link that's beneath this video. Just have a casual glance at it. Maybe even have a look at the YouTube membership. It's very easy. Click, 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 member. The little bell thing, dingy, ding, ding. That will remind you when a new episode comes up. All those things. They're all normal. Anyway, that's it. As always, if you have been, thank you for watching.